Mercury lamp, shown in the picture, emits radiation with a wavelength of 4.36 times 10 to the negative 7 meters. So we know that is at the end of the Roy G. Biv range, and that's also equal to 436 nanometers. What is the wavelength? It just gave it to us, but is asking us in centimeters. Start with meters, that's the base unit, and just do a simple conversion here with one conversion factor. 4.36 times 10 to the negative 7 meters. That's just what's given. We're going to use a conversion factor to get rid of meters and end up with the desired unit on the other side. Right, so meters cancel out. Now make sure this is equal. We learned this back in the first week or so of our class. 100 centimeters in 1 meter. You got to memorize some of these prefixes. We are just going to add 2 zeros to this, right? So we're going to increase that exponent by 2, and your answer is going to be 4.36 times 10 to the negative 5 centimeters. B, what region of the, well, it's blue, bluish. It's in the visible range, and it's going to be bluish. That's like 460-ish, I would say. Calculate the frequency of this radiation. The speed of light is equal to the wavelength times the frequency. Rearrange that, do the algebra first, save us a little time. Okay, we're going to solve for frequency. So divide through by lambda, and you get frequency is equal to the speed of light over lambda. We're already given that. All right, so the speed of light in your formula sheet is 2.998 times 10 to the 8 meters per second. All right, and the wavelength, let's use the 1 meters because that's, all right, so 4.36. Cancel, cancel. All right, let's get our calculator. 2.998 times 10 to the 8 divided by 4.36 times 10 to the negative 7. We need 3 significant figures because the only number they gave us had 3. So the 6, the 8, and that 7 rounds up. 6.88 times 10 to the 14 hertz, or per second, or seconds to the negative 1.